Hello again everyone, this is Sir Rick and I would like to welcome you all to another video tutorial in our Math 10 class. So before we start class, may I present to you the things that we need to accomplish for today. Our topics for today are division of polynomials and of course the remainder theorem. Now under the division of polynomials, we shall be looking into two processes. We have your long division and your synthetic division. Okay, so first things first class, let's recall what a polynomial expression is. Your math teacher when you were in grade 7 has mentioned that a polynomial expression always takes the form a sub n x raised to n plus a sub n minus 1 x raised to n minus 1 plus a sub n minus 2 x raised to n minus 2 plus and so on until the linear term a sub 1x plus the constant term a sub 0. And this polynomial expression must have the leading coefficient a sub n not equal to 0. Recall also class that in a polynomial expression, n is considered as the degree of the polynomial expression. And the degree of the polynomial expression must be a non-negative integer. That means to say that n can be 1, can be 2, can be 3, and so on, but it cannot be 1/2, it cannot be 3/4, it cannot be -2, it cannot be -7. So always take note, class, that the degree of the polynomial expression is a non-negative integer. Also, class, in a polynomial expression, a sub 0, a sub 1, and so on until a sub n minus 2, a sub n minus 1, and a sub n are called the coefficients of the polynomial expressions. And these coefficients of the polynomial expressions must be real numbers. In other words, class, a sub 0, a sub 1, a sub n minus 2, a sub n minus 1, and a sub n can be 1, can be -1/2, can be -7, can be 3/4, 4/5, and so on. So as long as they are real numbers. Now class, let's try dividing the polynomial 2x squared plus 5x minus 23 by another polynomial x plus 5. Let's try first dividing these polynomials using the long division. Okay, class. So when we are dividing a polynomial by another polynomial, the first thing that we have to do is to write it using the division symbol and ensure that the dividend is found inside and that the divisor is found outside the division symbol. Now, when we are done writing it so, we are now going to follow step number 1. Step number 1 says we are going to divide the first term of the dividend, which is, in this case, it's 2x squared, by the first term of the divisor. In this case, it's x. 2x squared divided by x will give us 2x, and the result, 2x, is written over the x term in the dividend. So we write it there. Now, once we're done doing that, we proceed to step number 2. So class, we are now going to multiply the partial quotient, which is 2x, by the divisor x plus 5, and we place the result below the dividend, lining up the terms. So we have 2x times x will now give me 2x squared, and 2x times 5 will give me 10x. After that, we are now going to proceed to step number 3, which means, or which says, that we are going to subtract the result from the corresponding terms in the dividend, and we bring down the next term. So we have 2x squared minus 2x now will give us 0, or that will those will cancel out, I should say. And then 5x minus 10x will now give me negative 5x, and we bring down negative 23. Proceed to step number 4. We divide negative 5x by x and place the result, negative 5, over the constant term in the dividend. So we have negative 5x divided by x will give me negative 5. And then step number 5, we multiply negative 5 by the divisor x plus 5 and place the result under the dividend and subtract. So negative 5 times x will give me negative 5x, and negative 5 times positive 5 will give me negative 25. And when we subtract negative 5x minus negative 5x, that will cancel out. Negative 23 minus negative 25 will give me an answer which is positive 2. So we now say that the quotient, therefore, of 2x squared plus 5x minus 23 divided by x plus 5 is 2x minus 5, and the remainder is 2. So we can write it as 2x squared plus 5x minus 23 all over x plus 5 is equal to 2x minus 5 plus the remainder 2 over x plus 5. Or we can also write it as 2x squared plus 5x minus 23 is now equal to the divisor x plus 5 times 2x minus 5 plus 2. In general, therefore, class, if p of x and d of x are polynomials with d of x not equal to 0, then we can write p of x divided by d of x, that is equal to the quotient q of x plus the remainder r of x all over the divisor d of x. Or we can also write it as p of x is equal to q of x times d of x plus r of x. Let's try another example, class. We divide 10x squared plus 2x to the fourth plus 8 plus 7x cubed by the polynomial 2x squared plus x minus 1. Now, you might have noticed, class, that the dividend is not arranged in its standard form, or it's not written in its standard form. That means to say that the degree is not arranged in descending powers of x. So the first thing that we have to do is to arrange the terms of the polynomial in descending powers of x, both the dividend and the divisor. So we write it therefore using long division and using the division symbol. We write it now as 2x to the fourth plus 7x cubed plus 10x squared plus 0x plus 8. Now notice again, class, that in the dividend, there is the inclusion of the missing term. So there is no linear term in the given, hence we are going to include the linear term, but it has to have a coefficient of 0. So 0x. And then since the divisor is already arranged in descending powers of x, or it's already written in its standard form, then we can write it as, or we can just copy it as 2x squared plus x minus 1. So there are two considerations here, class, before we proceed to division. First is we have to write both the dividend and the divisor in standard form. That means to say we have to arrange the terms in descending powers of x. And if ever there are terms that are missing, we have to include that term by writing a numerical coefficient of 0. So since we have done that, we are now ready to divide 2x to the fourth plus 7x cubed plus 10x squared plus 0x plus 8 divided by 2x squared plus x minus 1. So let's see. So the first thing that we do, again, just like what we did in the first example, we divide 2x to the fourth by 2x squared, and that gives me x squared. And then after dividing that, we multiply x squared by the divisor. So x squared times 2x squared is 2x to the fourth. X squared times x will give me x cubed, and x squared times negative 1 will give me x squared. Negative x squared, I should say. And then, if we are done, we are now going to subtract. 2x to the fourth minus 2x to the fourth will give us 0. 7x cubed minus x cubed will give me 6x cubed. And 10x squared minus negative x squared will give me positive 11x squared. And then I'll bring down 0x. And then we divide 6x cubed divided by 2x squared will give me positive 3x. And positive 3x times 2x squared will give me 6x cubed. 3x times x will give me 3x squared, and 3x times negative 1 will give me negative 3x. Again, we subtract. 6x cubed minus 6x cubed will give me 0. 11x squared minus 3x squared will give me 8x squared. 0x minus negative 3x will give me positive 3x, and then I'll bring down 8. And then we divide again 8x squared by 2x squared. So that gives me positive 4. And 4 times 2x squared will give me 8x squared. 4 times x will give me 4x. And 4 times negative 1 will give me negative 4. We subtract. 8x squared minus 8x squared will give me 0. 3x minus 4x will give me negative x. And 8 minus negative 4 will give me 12. Therefore, when we divide 2x to the fourth plus 7x cubed plus 10x squared plus 0x plus 8 by 2x squared plus x minus 1, the quotient is x squared plus 3x plus 4, and the remainder is negative x plus 12. Or we write that as 2x to the fourth plus 7x cubed plus 10x squared plus 8 divided by 2x squared plus x minus 1 is now equal to x squared plus 3x plus 4 plus the remainder negative x plus 12 all over the divisor 2x squared plus x minus 1. Okay, class, since you already know how to divide a polynomial by another polynomial using the long division method, I am going to teach you another method known as synthetic division. Synthetic division is actually a shorter procedure when a polynomial is to be divided by a binomial taking the form x minus c. So, let's take an example. What if we divide 3x cubed plus 4x squared plus 8 by the binomial x plus 2? So our given is 3x cubed plus 4x squared plus 8 divided by x plus 2. So the first thing that we will have to do is to arrange the coefficient of the dividend p of x in descending powers of x, placing zeros for the missing terms. So we have 3, 4, 0, that's the missing term, that's a linear term, and 8 is the constant term. Now, the leading coefficient, which is 3, becomes now the first entry of the third row. So we have it there. Okay, so after writing the coefficients and bringing down the leading coefficient of p of x, we are now ready to determine the value of c from the divisor. So notice that the divisor is x plus 2, and if you equate that with x minus c, the standard form of the divisor for this particular topic of synthetic division, then c must be equal to negative 2. And we write negative 2 at the extreme right of our synthetic division. So we have it here. So that c equals negative 2. After this, we can now proceed to step number 3. So step number 3, we are now going to write the first number in the second row. That is negative 6. Now, where did we get negative 6? That is the product of c, which is negative 2, and the number in the third row, which is 3, the one that we brought down. So 3 times negative 2 will give me negative 6. And then, we are now going to add the two terms, 4 and negative 6, and that will become the second number in the third row. 4 plus negative 6 will give me negative 2. Again, that is the sum of the numbers 4 and negative 6, the numbers above negative 2. Step number 4 is we are now going to repeat the procedure described in step 3 until the last number in the third row is obtained. So we have, okay, we have negative 2 times negative 2, that is C, that will give me positive 4. Okay, and 0 plus 4 will now give me 4. Finally, 4 times negative 2 will give me negative 8, and 0 or 8 plus negative 8 will give me an answer of 0. So finally now, we write the quotient. We now have, note, I should say before we write the quotient, note that the degree of the quotient q of x is 1 less than the degree of the polynomial function p of x, or the polynomial expression p of x. The entries in the third row give the coefficients of q of x and the remainder. So this one now will give us the quotient. So that means to say it's 3x squared. Because our dividend has a degree of 3, then we have to subtract 1 from it. We have therefore 3x squared minus 2x plus 4, and the remainder now is 0. So now we write it as 3x cubed plus 4x squared plus 8 divided by x plus 2 is now equal to 3x squared minus 2x plus 4. Okay, class, let's have this example. What about if we divide x to the fourth minus 5x cubed plus 8x squared plus 15x minus 2 by x minus 3? So, again, before we divide it, we have to inspect first whether the terms are arranged in descending powers of x or if there are missing terms. So since the terms are already arranged in descending powers of x and there are no missing terms, then we can proceed to synthetic division. So the coefficients are the coefficients of the dividend, I should say, are 1, negative 5, 8, 15, and negative 2, while the value of C in the divisor is 3. So since we are already able to set up our synthetic division, then we are now going to proceed. So the first thing that we do is we bring down the leading coefficient, that's 1. 1 is to be multiplied with C, so 1 times 3 will give me 3. Okay, and then we add negative 5 plus 3 will give me negative 2. Negative 2 will be multiplied to 3 again, to the value of C, which is 3. That gives me negative 2 times 3 will give me negative 6. And positive 8 plus negative 6 will give me positive 2. And then, we are now going to multiply. 2 times 3 will give me 6. 15 plus 6 will give me 21. 21 times 3 will give me positive 63, and negative 2 plus 63 will give me positive 61. Okay, class, so since we were already able to complete our synthetic division process, we are now ready to write our quotient and our remainder. Again, if a polynomial expression is divided by a linear binomial class, the quotient is, or the degree of the quotient, I should say, is always 1 less than the degree of our dividend. Now, if the degree of our dividend in this particular example is 4, then therefore our quotient should have a degree of 3. And where do we get the quotients, or the quotient, I should say? It would be on the entries in the third row. So we now ready to write our quotient as x to the third power minus 2x squared plus 2x plus 21. And our remainder now will be equal to 61. And so now we write it as x to the fourth minus 5x cubed plus 8x squared plus 15x minus 2 all over x minus 3, that must be equal to x cubed minus 2x squared plus 2x plus 21 plus the remainder 61 all over x minus 3. Now, what about this example class? We have 6x to the fifth power minus x to the fourth power minus 32x cubed minus 20x squared plus 5x plus 8 divided by 2x minus 3. Now, notice class that our dividend or the terms of our dividend are already arranged in descending powers of x and that there are no missing terms. However, class, the divisor 2x minus 3 does not take the form x minus c. So we first have to translate 2x minus 3 into the form x minus c by dividing every term of our divisor by 2. Hence, it now becomes 6x to the fifth minus x to the fourth minus 32x cubed minus 20x squared plus 5x plus 8 divided by x minus 3 over 2. Again, x minus 3 over 2 came from dividing every term of the divisor by 2 to ensure that its leading coefficient is 1. So, we are now ready to set up the coefficients or our synthetic division using the coefficients of our dividend and our divisor. So, we have 6, negative 1, negative 32, negative 20, 5, and 8 as coefficients of our dividend. And the value of c in our divisor is 3 over 2. So we now have, we bring down 6. 6 times 3 is 18 over 2 is 9. And negative 1 plus 9 will give me positive 8. 8 times 3 over 2 will give me 12. And negative 32 plus 12 will give me negative 20. Next, negative 20 times 3 over 2 will give me negative 30, and negative 20 plus negative 30 will give me negative 50. Next, negative 50 times 3 over 2 will give me negative 75, and 5 plus negative 75 will give me negative 70. Finally, we have negative 70 times 3 over 2 will give me negative 105, and 8 plus negative 105 will give me negative 97. Now, notice class that the entries in the third row are in color red. That means to say they are not yet final. Now, since we divided the terms of our divisor by 2 a while ago, we are also going to divide the entries in the third row by 2. Hence, we have 6 divided by 2 will give me 3. 8 divided by 2 will give me 4. Negative 20 divided by 2 will give me negative 10. Negative 50 divided by 2 will give me negative 25, and negative 70 divided by 2 will give me negative 35. Therefore, we can now write our final answer as 6x to the fifth minus x to the fourth minus 32x cubed minus 20x squared plus 5x plus 8 divided by 2x minus 3 is now equal to 3x to the fourth plus 4x cubed minus 10x squared minus 25x minus 35 plus negative 97 over 2x minus 3. Okay, class. So we are now done with long division and synthetic division. Before we proceed to the last topic, may we go back to our very first example earlier. What is the remainder when 2x squared plus 5x minus 23 is divided by x plus 5? Now, earlier class, we have shown that using long division, we were able to find out that the remainder is actually equal to 2. Now, class, if we are just interested of the remainder when a polynomial is divided by another polynomial of the form x minus c, we can do that. We can determine the remainder even without performing long division or synthetic division. So class, we have the theorem called as the remainder theorem. Again, this is applied when we are interested of the remainder when a polynomial is divided by another polynomial of the form x minus c. What does the theorem say? Remainder theorem states that if a polynomial p of x is divided by x minus c, the remainder is a constant and is equal to p of c. Now, to illustrate this theorem, let's have an example. What is the remainder when 2x squared plus 5x minus 23 is divided by x plus 5? To recall, this was our first example earlier class. So, using remainder theorem, we now have, or we now let, I should say, p of x be equal to 2x squared plus 5x minus 23. That is our dividend. So, since we are interested of the remainder, then we are now going to replace x by negative 5, which is the value of my c. So we have uh, x plus 5, which is our divisor. That must be x minus c, so c must be equal to negative 5. So we replace x, I repeat, by negative 5. So we have p of negative 5 is equal to 2 times negative 5 squared plus 5 times negative 5 minus 23. And simplifying this, we have 2 times 25 plus negative 25 minus 23. And simplifying this further, we have 50 minus 25 minus 23, which gives me now the value of p of negative 5, which is equal to 2. Therefore, the remainder of 2x squared plus 5x minus 23 when divided by x plus 5 is 2. Again, this is using our remainder theorem. Let's have another example class. What is the remainder when 2x to the fourth plus 5x cubed plus 2x squared minus 7x minus 15 is divided by 2x minus 3? So, we let p of x be equal to 2x to the fourth plus 5x cubed plus 2x squared minus 7x minus 15. And we let c be equal to 3 over 2. That came from 2x minus 3. Since the divisor does not take the form x minus c, then we have to divide the terms of the divisor by 2. So that becomes x minus 3 halves. Therefore, the value of c is 3 over 2. So replacing x now with 3 over 2, that gives me 2 times 3 over 2 raised to the fourth power plus 5 times 3 over 2 raised to the third power plus 2 times 3 over 2 raised to the second power minus 7 times 3 over 2 minus 15. And simplifying this class will give us a value of p of 3 over 2 equals 6. Therefore, the remainder when 2x to the fourth plus 5x cubed plus 2x squared minus 7x minus 15 is divided by 2x minus 3 is 6. So that ends our video tutorial for this day, class. Watch out for my next videos. Be healthy, be safe. Until then,